Can accidents happen? Yes, that's why you have to be safe. And you need to understand where you're putting your gauges on, why you're putting your gauges on. But this doesn't make a difference if you're working on a standard synthetic refrigerant. It doesn't matter. You need to understand that equipment you're working on. And welcome to another CO2 Monday and the Refrigeration Mentor podcast. I'm your host, Trevor Matthews. So excited, so happy, and so grateful each week. All of you come out, hang out, learn a little bit about CO2, and really help me keep pushing harder to get top guests, to get more information out to the industry, because I really believe that together, collectively, we can grow the knowledge base in CO2 globally. This is why I do it each week. I was only going to do this for 12 weeks, and I'm way over 30 weeks of doing this, and I'm booked all the way out into January. So there's a need for this, and I really want to thank everybody who has been on the show already, who continue to want to come back, and people who want to come on again, because this is really what it's all about, a community of us trying to share the knowledge to help everyone grow. At the end of the day, this is why I do this, is really to help you out there as well as help myself grow, because when I do these, I have to go and do some research, and I got to learn more about CO2 and refrigeration and really build my knowledge base so I can bring you guys the top knowledge. And I really appreciate all the support from all of you, and really appreciate all the support on the podcast. It's grown crazily, and it's all because of all of you out there. Today, I was supposed to have Robert Della Ventura from Heatcraft late rescheduling had to happen, and so he's going to be coming on in 3 weeks, I believe it is, which I'm super excited about. But the show must go on. There's no stopping this. I'm not shutting her down for because someone had scheduling issues or something happened, an emergency. But what I want to do and talk about today is any questions that you have on CO2. I'm going to try to help answer it. And if not, there's some material that I'm going to go through that I use on a daily, weekly, monthly basis. I use either for myself learning, to review, to help other technicians out there, companies out there, because for me, it's really important to share the knowledge. The knowledge is out there. I build CO2 programs for manufacturers. I build CO2 programs for consultants. I build CO2 programs for contractors right now, and I'm doing this constantly. I got a lot of CO2 programs going on right as we speak to educate the industry from all parts of the globe. And I'm really blessed that I have the opportunity to be able to share this knowledge. And I'm really grateful that I have the opportunity to work with some of the best in the industry who share their knowledge with me so I can share it with more people. So if anyone has any questions, they want to unmute, ask a question about CO2, something that they're thinking about, please do that. For those who are listening, I'm going to go through some stuff probably up on the screen here in a few minutes, but anybody who has any questions, you can unmute yourself, shoot it in the chat box, and we're going to get going here. Okay. I'll share my screen. I'm going to do my best for the people that are listening to this on the podcast, and I'm getting better and better at that. So one of the things that's so important to understand to grow your CO2 knowledge is take the time to do research. I've done multiple podcasts on this. I've done multiple webinars on doing research. But one of the things that is sometimes it's really hard to find the information you need. There are some manufacturers out there that are really good at putting information out there. There are some other manufacturers that it takes a little bit to find the information. And what I try to do is I've tried to really look for the information in multiple places. I like to use Google to find the first, like the manual, but I like to go to that manufacturer's website and then find it that way. And when you start to do that, it makes things become so much easier. And there's probably 4 or 5 manufacturers. Well, there's more than that, to be honest. There's a lot of manufacturers that I follow, and I do a lot of research on their equipment. This is why I'm getting better. I am doing the research. I am reading. I'm talking to people. I'm going out to the site visits. I'm going to sites, seeing the equipment run, working with technicians, talking to the manufacturer, talking to the technician. And if you want to get good, that's what you got to do. You have to put the work in. You have to put the time in. You need to take this action, because if you don't now, when? That's the question. Start learning it now, and then 1, 2, 3, or 4 years down the road, when there's a lot more CO2, you're going to be well prepared, better prepared. I'll tell you that. So I'm going to give you a couple of manuals that I work off, that I've learned a lot of stuff from. Not going to go into the component manufacturers, because you need to be going to the Danfosses, the Bitzers, the Emersons. You need to be going to those ones to find those specific parts, the Sporlans, whoever it is. You need to go into those to find that specific part that you're working on for CO2. It's a definite, because if you're not doing this, you're going to take a lot longer to learn it. If you're just trying to wing it and learn it, it's going to be even longer. I've tried to do that. That is difficult to do. But when you get the manuals, and I highly recommend, you got to read a lot of different manufacturers' manuals. And over time, you're going to be able to start reading between the lines, and stuff is going to make more sense. The more you read on it, the more you see it, the more you do it. If you're just going out there and trying to wing it and trying to learn CO2 on the fly, it's going to be very difficult. It's going to take a long time to do it. I know I talked to technicians who have tried this and spent many years, and finally said, man, after I started going back and started reading the proper material, putting 2 and 2 together, being out in the field, touching the components, touching the equipment, more stuff start to make sense. And this is what you got to do. You got to do it constantly, daily, weekly rituals on researching this stuff. So we're going to go through a few of the manuals that I look up and I really enjoy looking through. So we're going to start with Kysor Warren. I did a quick search on it anyway. The quickest way to find anybody's CO2 manual, do the manufacturer's name. So if it's Kysor Warren, Hill Phoenix, Advancer, Hussmann, System LMP, whatever it is, whoever it is, you do their name of the manufacturer and then CO2 manual. So this is a good one. It pops up. Kysor Warren is great. It pops up right away, which is good. So this is it. I always like to go back and find it through their website. I'm not going to spend time doing that today, but what you need to do is go on Google and search that manufacturer. I really like this manual because they have a lot of pictures, and a lot of other manufacturers don't have as many pictures, which is good and bad in a sense, because you see a picture of it and you think it looks that way, but when you see it in the field, it looks a little bit different, because this can happen because there's different models, there's different options on the equipment. So another one that I use is, once again, Hill Phoenix. Here I wrote a bunch of them out. So Hill Phoenix is another one. So Advancer. So you go down, Advancer CO2 booster system, PDF. So you always want to look where it says PDF, because then it doesn't take you to another website that's actual PDF. So here's the Hill Phoenix one. We'll do another one. So Hussmann CO2 manual. And we'll get to some good stuff in a second here. So look at Hussmann technical document. So this one here, similar to the System LMP one, but you now need to go to Evapco and download the new updated version of the System LMP transcritical rack option. But this is important. So I got 3 different big manufacturers with 3 different operation and installation manual. This is important. This is key to your success, is reading these. And I learned this when I worked at Emerson. This was a big thing that I learned working for the manufacturer. I used to be like maybe a lot of technicians or refrigeration professionals out there. It doesn't even have to be technicians. It's really anybody. Start skimming through what you're trying to find. You know, oh man, that's 40 pages. Let me just try to find the information that I need. I've done this for years. And until I realized, till I was working for the manufacturer and really looked at it and was like, oh man, I've skipped all this great information. A good one is in the application engineering bulletins, Copeland design. Like, they make some amazing manuals, but if you don't read the first 4 pages that talk about the safety, the limitations, all this stuff, because I used to skip all that stuff, there is some key information in that stuff. And after a while, it's going to be the repetitive stuff. So if you read it 3 or 4 times, then that's when you can start skipping those manuals. But until you read those, it talks about the safety, it talks about electrical. I used to skip that stuff. Don't skip that stuff. When you're doing manuals, you need to dive in and really look at everything that they say, because sometimes there's little notes that aren't highlighted that are like, wow, I did not know that. You need 5 degrees of subcooling going into that injection valve to make sure that they're properly getting the injection, whatever it is. You need to read the fine details. And that's the game changer of refrigeration professionals and people just winging it. That's it, hands down. Because you're going to learn a lot faster when you spend the time, you put the work in. What I really like about this manual, so those of you that can see this, this is the Eco CO2 eCO2 Boost manual by Kysor Warren. I'm not going to read all of this, but this is the step-by-step. I want to go through some things. As you can see, they got some pictures of it, which kind of give you a sense. If you've never seen a CO2 system before, because I'm training, lots of the training I do are technicians who are already working on CO2 systems. Like they spend the last couple of years even working on it. I'm bringing them to another level. You know, so if you're new to a CO2 system, what's great to this, it's kind of showing you what it would look like. If you worked on supermarket before, oh man, that kind of looks similar to what I'm working on, maybe a little bit different where you got compressors on top and below, but manufacturers are doing that now. They're building their racks more compact. It's just the way it is, and you're going to see more and more of this. But what I like about this, it kind of gives you a quick breakdown on the system overview. You'll see that it gives you a good diagram on where the compressors are, gas cooler, that high pressure valve, that flash gas bypass valve, then your flash tank, and then down into your subcritical side of the system. It talks about the refrigeration cycle. And this one right here is really key. I really like this. A couple of manufacturers put this into their manuals. So they use a pH diagram. And if you don't know what a pH diagram is, you need to go to Danfoss Cool Selector and then click on Log pH Diagrams and go to R744. You got to go to that, and then you'll get a nice diagram similar to this here. But the big thing is the points they put on it. And this is like, this is really where I learned it from when I worked at Copeland, is like putting the compressors on there and the system on there to understand the heat of rejection, understand the heat of compression, the net refrigeration effect. This is real key for CO2, understanding this. When you start to place the equipment versus the enthalpy diagram, and I do this in all my trainings. It doesn't matter if it's compressor training, it doesn't matter if it's supermarket training, it doesn't matter if it's CO2 training. I do this over and over and over again because it's a repetitive thing. If you haven't seen it in 5 years, then it's like, okay, you kind of forget it. Even me, I do it all the time. I still forget stuff. So it's important to do that. But as you can see on here, you go from 1 to 2. So that's where the suction of your medium temp or transcritical compressor is to your discharge of your compressor. And it kind of explains it. The CO2 refrigerant gas gains pressure and heat through the medium temperature compressor. Step by step, you need to understand this. This is what's key. This makes the difference of a good technician and a great technician. When you can explain what's exactly happening in the pipes. And you can do this. When you are doing this and you understand and you think, okay, I'm above that transcritical point. We're above 88 or 87.8. We're above 31 degrees Celsius. I know the gas that's in that gas cooler is not a liquid, it's not a vapor, it's a fluid. You know, you're in the supercritical, and you got to think about it, and you got to see videos. There's lots of videos on there. On YouTube, go to YouTube and look up transcritical CO2 fluid or supercritical fluid. You'll find some on there. And you'll see what it looks like, what it actually looks like inside the pipe, inside that gas cooler. And this is what's important. When you can start seeing inside the pipe, it's a game changer, because that's the way I feel. After I was training on CO2 for so long and working on equipment and training on demos and stuff, and I could really start to understand what was in that specific pipe at that point and the flow. That is game changing. The flow, when you understand what direction that gas is going, why it's going that way, the mass flow, how much oil is in it, oil carryover, all this stuff, and why that is happening. This is where the curiosity begins, and then you start to do more research. I really believe more of us need to be curious about what's going on in a system, because that's where you start to learn more. The more curious you are, the more you're going to learn, because you're going to ask more questions. And I'm noticing this more and more as I progress through some of my CO2 training programs. The first session or first 2 sessions, there are some good questions, and the questions start to grow by the end of it. By the 3rd and 4th or 5th session, man, there is a lot of good questions coming in, more and more questions, because this is the way I develop CO2 programs. Is the week before, I want them to come in with a lot of questions that's on their mind, because when you come in with more questions because you're curious of certain answers or how something works, that's where great conversations are started. And I've seen me in programs where we had there's set agenda on what we need to talk about. But when a good few questions come in, those questions are more important to be answered and talked about because everyone's learning at that point. And the point of it is when you're curious, you ask the right question, you get, well, sometimes you don't get an answer because I don't have all the answers in the program, but I can go find that answer out. There's a ton of experts even here sitting, listening to me, hanging out today that are way smarter in CO2 than I am. But you know what? They're willing to share their knowledge. Don't be afraid to ask the questions. And like in this manual here, it goes through this pH diagram and it talks about the different steps. Each step, what is happening in that step. That's one thing that I like about it. Also, it talks about the working pressures. A lot of people are, concerned about the pressures, and as well as you should be. They are higher pressures, okay? And it's understandable to be concerned, just like it was 25, 30 years ago when 410 came out. A lot of people were concerned, oh, it's higher pressures, it's going to blow up, blah, blah, blah. 100% you need to be more safe. And what I mean by that is learning and understanding the equipment you're working on. I don't think you should just be going out and working on equipment that you don't have a clue of how it's working or understanding. I highly recommend taking some training, doing some research. You have to do that stuff, especially for CO2. But the manufacturers that are building equipment today, they are making it safer than it has ever been for CO2. Why? Is because I went and I found information on 20 years ago on the type of equipment that was being built to what is being built now with the safeties and the check valves and the shutdown procedures and emergency shutdowns. I've seen, and I've been reading a lot. Can accidents happen? Yes, that's why you have to be safe. And you need to understand where you're putting your gauges on, why you're putting your gauges on. But this doesn't make a difference if you're working on a standard synthetic refrigerant. It doesn't matter. You need to understand that equipment you're working on. And I really like how they put the working pressures in there, gives it a breakdown. A low side could be between 188 and 218 PSI or 13 to 15 bar. And I really recommend to everybody that I train, you need to start learning different units. Hands down, you need to know Fahrenheit, you need to know Celsius, you need to know PSI, you need to know bar. At least you need to know how to convert it. You need to understand how to convert it. So 1 bar equals 14.5 PSI. And all you need to do is get a unit converter and look that stuff up, or Fahrenheit and Celsius, because you're going to see more and more equipment have different units on it. And it's just better in yourself understanding these different things, different units, because when you see something that you don't understand, don't run away from it, learn from it, be curious about it. So then you get the different pressures, medium temp suction, 377 to 435, 26 to 30 bar, and then the high side is 650 to 1495, so 45.103 bar. Okay, so 1495 PSI. So they say this is what the system's going to run up to. So, okay, so now just think about that. Oh, it's 1500 PSI. Okay, that's pressure, but it's in the pipes. They've designed it to be in the pipes, not out of the pipes. And what you need to do is study that system before you work on it. Really, if you're installing the system, you want to understand how you're supposed to install it. So even if you're just doing the pipe work, you should understand that rack. You should understand how it works, how it operates. Even if, like, piping is a very important job. Lots of people think, oh, it's not important. That's probably one of the most important jobs on a CO2 system, on any system. That's really why we have to have all these regulations. If all the refrigerants stayed in all the systems and never leaked, we probably wouldn't be going, well, we might have just stayed with CO2, but we probably wouldn't be going to natural refrigerants because we wouldn't have any systems that are leaking, but systems do leak, right? And that's why piping is so important. Pressure testing, leak testing. As you can see, as we go down through this manual, they have a lot of great things. They talk about the low pressure, low temp compressors. They get into the high pressure expansion valve, and they talk about it. Like, depending on ambience, the mixture can be as high as 45 to 50%. So that means the flash gas. That means they're bypassing up to 55%, depending on the image. That's a huge amount of bypass. But as you go down through this manual, you'll see there's a lot of options to reduce that. And that's what a lot of manufacturers are doing. One of the big things is all these little key notes here that are in blue. Like, these compressors are typically designed to withstand pressures exceeding system design pressures of 1740 psi or 120 bar on the high side, and 652 45 bar and the intermediate pressure stage. So this is the stuff that you really want to understand, right, on the manufacturer's equipment. And by going through this, you're going to see in other manufacturers' manuals, there's a lot of similarities. You're going to see a lot of similar pressures they're going to talk about. You're going to see a lot of different components that they're going to talk about. And like flash tank, this term here, I only use flash tank, but I hear more and more people calling it a receiver, and which it can be a receiver. And it's important to understand the terminology. The terminology is key in refrigeration, because I've seen many people mix up their terminology just in TD, not even in CO2, just in regular refrigeration. I've seen lots of people be talking about a topic, but they're talking two different about two different things, because there's multiple terminology for the same thing in our industry. And same with this here, like flash tank, receiver. Okay, so just that's something to understand and to think about. As we get down through as you can see, there's a lot of picture. What's an auxiliary condensing unit? It's optional. For some end users, it's not optional. And more companies, more technicians want to have auxiliary units because it makes a world of difference. If you have a unit that you can turn on and run and not worry about blowing the charge off or releasing the refrigerant, that is huge, because now you can feel a bit more confident, not as rushed when you're servicing an equipment. So any end user that's out there thinking about getting a CO2 system, I highly recommend getting this optional auxiliary unit. You should be. I don't even know why it's an option not to get it, because now this gives the people working on your equipment a bit of peace of mind, and they don't have to rush. Because I know there's some technicians out there that feel like they have to rush, especially when there's a situation where they have to work on the equipment. If they have to work on the transcritical header or something like that, they don't have that peace of mind. And then other contractors and technicians that I talk to about when they have the auxiliary, they're like, wow, it's pretty good that we have this option, because now if I take a little longer to fix a problem, or I can pull that proper evacuation, because I know that I'm not going to lose it, especially if it's in the middle of the summer when it's super hot outside. And as you go through any manual, you need to take notes. This is a big thing that I talked about so many times. You need to take notes. Take away what you are getting from it, because you can read this. This one here is a nice short one, 27 pages. But you should take notes, and the next time you read it, then you probably can take some different notes potentially. And then you're going to start building your own collateral, your own stuff not collateral, I guess, your own like little knowledge book that you'll be able to refer back to. And you should see the books that I have and the notes that I take. I take so many notes. I actually take too much notes because I'm still learning how to properly take notes, to be honest with you, because I used to write verbatim. If I go to a training, I'm writing verbatim, which is the wrong way to take notes. It's to take the key point, and I'm still working on that. These are things that I'm working on, but I know that it's important for me to take the notes. So if I have to write it almost all verbatim, what I do is then I go back and rewrite the notes again and rewrite them again until it's shorter, to the point, and I understand that specific thing. You could see definitely in here, we'll go through it, and you'll see here in the safety ones, for an example, on like what type of gas, what grade of gas. Like, they put all the different types of grades in this manual. You know, you got bone dry, you got Coleman instrument grade, you got pure clean. There's lots of different ones. And I keep hearing this from different contractors and technicians out there, that there's a shortage of CO2, or they're running into issues of supply of CO2 for their systems. So you want to be aware of what refrigerant you can use, how to install it, or how to charge up a system. This is very important stuff. It talks about in the manuals. And like here, it says for their equipment, because some other manufacturers say different, for their equipment, Coleman grade or higher purity CO2 refrigerant which contains less than 0.01% impurities are recommended by Kysor Warren for use in CO2 transcritical booster system. So this is important. You need to follow that manufacturer's information. And these also are guidelines. And you're going to see down below what I mean by guidelines, because there are certain situations in certain provinces, certain states, certain countries where you have to follow the local codes, authority of jurisdiction. This is so important because I do trainings globally, so I have people from all over the place. So I'm learning about these different areas, and it's different. And for me, I would always want to try to go to the highest standard, especially for safety. When we're talking about safety, you want to be super safe in there. A leak detection system. This is another great one. I do this all the time in my supermarket trainings as well. When I'm in my supermarket trainings, I really want to teach the guys about leak detectors. This is important. We're going to see more and more of it, not only with CO2, but with A2Ls and natural refrigerants. You're going to start seeing more leak detectors. There's going to be more safety devices, more regulations coming out, and this is the stuff you need to learn. Here's a question. The auxiliary condensing unit cost versus the cost of CO2 ROI, and if you need to install standby genset, the cost all negates the cost of burping off CO2. So that's a great question. Okay, what is the cost of auxiliary condensing unit? So for me, like in the cost of a generator, okay, or genset, well, for me, it has nothing to even do with a genset. So the genset is if your store goes down, like the power goes out, your power goes out, everything's down. Okay, so you have a genset to run the power, so it just runs and keeps your flash tank cold. That's not why I think you should have an auxiliary unit. I think you should have an auxiliary unit, 1, 2, 3, 4, 5, 6, whatever horsepower is needed, so technicians can service that system without worrying about having to blow off a charge. Because I've even talked with contractors that they did release the charge to work on the system because they didn't know. Nobody trained them, and they're getting thrown in these situations to work on equipment that they never learned about. And this is the worst way to learn. Lots of people just throw it in there, throw them in over their head, they'll figure it out. This is the worst thing that was ever done to me in refrigeration, is like, hey, you're a phone call away. No, we need to be training technicians out there, for refrigeration professionals, get their confidence up, get their skill level up. They should not be thrown in over their head. And it's still happening out there. I do trainings now with lots of people, and they say, Trevor, I'm working on this CO2 transcritical system. Never took a day of training. Nobody showed me. The manufacturer didn't come out, and I know it's hard because lots of manufacturers selling a lot of equipment. It's hard to train everyone when you're selling 100, 200, 500, 1,000, 10,000 pieces of CO2 equipment. It's difficult. And then what happens is I talk to even the manufacturers want to train more, but it's bandwidth to have people to go out and train. So they can go out, and a lot of them are good. All the big manufacturers I talk to, they send a service rep out to the site, and some is paid and some is, I can't remember, some are paid and some aren't paid to do it. It all depends on the manufacturer. But when they get out to the site, they'll train a couple of people. But they rely on those people that learned that was there to really train the other technicians. And if that contractor can't do that, that's where, when they have 4 stores going on at a time, that's when we have people that haven't been trained, So for that auxiliary condensing unit cost versus the CO2 charge, I really think that it should be in there for service applications. Then if you have a generator to run on it to keep it cold without blowing it off, so be it, but I really think it's for service, because I hear this a lot as well. CO2 is great. I can just blow the charge, like I can blow it off because it's a natural refrigerant. That's not what you should be doing. If there's 1,000 pounds in there, you shouldn't be blowing off 1,000 pounds because it takes a while to add that gas in. You need to learn how to either pump the circuits down, pump it in other parts of the system, where you can have time to work on that. You don't want to be blowing it off because this costs your customer money. Oh, well, it's inexpensive. It's only a few dollars a pound. 1,000 pounds, if it's $2 a pound, that's $2,000 to the customer. Is the hourly rate of a technician more than that $2,000? I don't think like that. I think, how do we best serve the customer, make my job super easy as well, because charging it takes a long time, so it's everyone has their own opinion. That's just my opinion. I think there should be auxiliary units. I don't think we should just be blowing charges just to work on equipment. I think we should be smart about it, understanding how to pump down a system, how to pump down a circuit, and release what you need to. Because I know for sure CO2 is going to be regulated. CO2, you don't, just because it's a global warming potential of 1, you shouldn't just be blowing it off, because it's still not good for the environment. Even though it's CO2 or even natural refrigerants, it still has a global warming potential. It's going to be regulated at some point. When? I don't know. I got a question here. What % of grocery stores have a backup gen set? It all depends. I know some stores that end users, all their stores, they put a backup gen set. Some other ones don't have even an auxiliary unit. So it all depends on where you're located. So I think that's the big thing for having % of grocery store. I know, I think from what I hear, more in Canada that is done. I'm not sure about the States and the number. If anybody knows the percentage of grocery stores that have a backup gen set for their CO2 system, please put it in the chat. Let's try to share some more knowledge. But I don't know. I think more in Canada I've been hearing, because it's the customers and the technicians that I've been working here that's been talking about that. As we go through this manual, it talks about the pressure reliefs. This is one great thing that I love about this manual as well. It talks about discharge line blockages. Okay, rack controller set at 1435 should shut down that shut down those compressors. So this is what you got to understand. There's 1, 2, 3, 4, sometimes 5 lines of defense to shut down a system before you're causing a pressure relief. Okay, and as you can see here, we got a rack controller set for 435 to shut down, high pressure switch at 1570, pressure relief at 1740. So we got 1, 2, 3 lines of defense for this one, this example here. We could probably put in leak detector. A leak detector could be in there that would help something to shut down. But this is for discharge line blockages. For low temp, they got 2, high pressure switch at 480 or 33 bar, pressure relief at 625 or 652, 43 to 45 bar. Once again, you really need to understand your local code, authority for jurisdictions, because here in Canada, certain places, as you can, I'm going to show you here, see how they have 2, it's hard to see, dual manifold pressure relief. So my understanding here, depending on where you're in Canada, they have to be the same pressure. So Advancer, when I was being trained by Advancer Europe, they'll have, say, a 45 bar and I think it's a 60 bar. I'll have to double check. I can't remember the 2 pressure reliefs. I'll have to double check again. So you can switch it over when you're working on the equipment. But here in Ontario, I know I was told, and I was at one site where there are both 45. And I think that's the regulations here. Will the regulations be different somewhere in the US, in the UK, in Australia? Yeah, that's why you need to look that stuff up and really understand that stuff. There's the suction line pressure reliefs, auxiliary condensing units. I found an error. I find lots of little errors in manuals. So, but auxiliary condensing unit optional. Once again, this is optional for 652 rated to flash tank. So this would turn on, as you can see here. It's a little. It doesn't say the size of this little auxiliary cooling unit, but they're not very big. And this is to release to hold the charge. I am sure a large charge system is more expensive than the auxiliary unit. And if it's not 1, maybe 2 charges would pay for that unit. But someone would have to give me the numbers, because I don't exactly know. I don't do sales on that stuff. So we get into inspection of placement of material. This stuff is important, really, really important. Diving in on understanding the model numbers, and note if parts are missing, contact technical sales support. You need to do this. I've been talking to more and more technicians out there saying equipment's coming with missing parts, just because there's such a delay and supply chain issues. People are saying it's getting better, but it's still happening out there. You could be getting equipment, and I know 2 or 3 people right now are selling an equipment and they only have half of it. They get in a rack and there's no controller on it. So this stuff is happening. So what you do with it, you deal with it. You don't cry, you don't complain about it. You just take the action, get what you can do done, and figure out how to continue on. The good technician, the good contractors, they're keep going. They're fixing it, they're putting it in, they're waiting, they're coming up with a strategy on when to get the stuff, and the deadlines don't change. The end user deadlines a lot of times don't change. So you're always put under the gun in our industry, it seems. Even when I was on the tools, it was like 6 months for rental, 4 months, 3 months, 2 months, 6 weeks. It's always get more and more and more and done. But sometimes we just need to sit back, take a breather, look at what we can do at this point, do that, and then talk about the next steps. It's just what you have to do. It's kind of like today, my guest unfortunately couldn't make it, and now we're doing something about it. We're talking, we're having a conversation here. And I don't think one person has left yet, so thank you so much for sticking through this. But as you can go through these different manuals, there's a lot of different key points. You may not be doing the aerial lifts or the hoisting of this rack, but they put it on there on how to do it properly. And this is how you can learn. Because at some point in your career, you might have to do that. You might have to understand where you're rigging this unit. Maybe it's going up on a building. Maybe it's going into, onto a mezzanine somewhere. And this is important why you want to read these different manuals. System installation, they dive into. Once again, this is where a key points come in on how to properly install these systems. And each manufacturer is going to have different ways of doing it. But as you read these larger manufacturers' information, you're going to see consistency on the safety aspects, on the installation. They want you done professionally. And especially all the contractors that I'm dealing with that are installing stores now, like I talk to the technicians that are doing the installation, and they're like, some of their things are like, I need to make sure that this stuff is perfectly aligned, perfectly straight. Because we know, all of us on here are refrigeration professionals, but we know a lot of the times it doesn't matter about the refrigeration, as long as it stays cold and it looks good. The looks are more important than actually how the equipment runs a lot of the time. And so the good technicians that I know, they spend a lot of time making it look good. That's why sometimes the job's taking a little longer, because you want it to make sure it looks keen for that end user. Because at the end of the day, they're going to be looking at the cases, and they're going to be looking at the walk-ins, and they're going to be looking at the fixtures of it. So and that's our job too. We want to do an awesome job on that, as well as the installation of it. And as you can see, the piping supports how you do it. The slope is no different. You need to slope back to your compressors. It doesn't matter if it's the supermarket, the standard refrigerant, or CO2. Same rules and principles apply, and you need to look into that. Talks about P traps. There's a good idea. Double P traps are presented for 20-foot risers, and so what that means is you got a P trap at the bottom, and then you got P trap at the top. I did this 15 years ago. It's the way I was piping systems 15 years ago. And some people I talked to said they never done that before. That's the way I did it. That's the way I learned how to do it. Testing and evacuation. This is so important. This is key. If you want longevity of a CO2 system, you got to follow these principles and practices. I had Jake Henderson on, I think it was episode, I don't remember, maybe 26, but he talked about how important it is to properly pressure test and evacuate. And this is what the manufacturers talk about all the time. And I know that we're under the gun a lot of the times as technicians and as professionals out there to get it up and running. But this is the most important. If you're a delay and people are mad at you at that point, and upset, no, we're losing time and materials and costing us the business, you got to think of the total cost of that equipment. And when you install the equipment properly the first time, with no leaks, no moisture in the system, that's when that system is going to last a lot longer. No leaks, no moisture. And by doing the proper pressure test, proper evacuation, that's when things start to change, right? Because there's systems out there that I've talked to technicians, they're like, I want to work on more CO2 stores, but the ones that we have, they don't have any issues. If they do, there's not very many issues. There are some other contractors that have a lot of stores, and there's only a few technicians that are dealing with the issues because there's not enough experience in their business yet to get out there. And a lot of refrigeration professionals are kind of, I don't want to take that call at that CO2 store. I haven't been trained yet. I haven't been learned, and they're wary about it. And I totally understand because it's something new, it's something different. But if you spend the time reading manuals like this, it's going to give you kind of an outlook on what it's all about, what the system's doing. Because a lot of the technicians that I talk to, professionals that I talk to that are out servicing these stores, the same calls that are coming up at a standard refrigeration stores are the same as the ones on the CO2 stores. Doors left open, case frozen up, fan motor out. So it's really what you want to do is just go back to the basics. Go back to the basics. And like here, they talk about triple evacuation. This is key for a supermarket. CO2 refrigeration, sorry. There's lots of people out there say that triple evacuation there's no point of doing it. For me, CO2, you need to do a triple evacuation. And what that triple evacuation is, and it explains it right in here. If you've never done it before, it explains it. Pull the system down to 1,000 microns plus or minus 50. Close the vacuum header valves. If the system cannot maintain vacuum, return to atmospheric pressure. Check for leaks, as previously said. When it maintains 1,000 for 30 minutes, break the vacuum with dry nitrogen. 30 minutes to 2 psi. So this is important. And every manufacturer that I talked to so far, they want you to do a triple CO2 manufacturer. They want you to do a triple evacuation. And why this is a thing is that potentially you could freeze moisture in the system, and that will cause you pull it down so low. If there's any water in the system, you could freeze it, and then that could be moisture in your system. So with doing the triple evacuation, if you do freeze any moisture or water in the system, you pull it back up to pressure, and then if it's frozen, it will not be frozen anymore. I think it's minus 12. I can't remember what it is to freeze moisture. But you break it, you do the evacuation again. You break it, you do it again to get anything out. And it's really kind of when you're purging, you go through it. Second evacuation down to 500. You hold it for 30 minutes, do it again. And as you can see, third vacuum, holding below 500 microns. And every manufacturer I'm reading, a lot of them say that. If you know a manufacturer that doesn't say that, please reach out, shoot me an email, send me a message. I'd love to see what they say because I'm still learning too. I'm still learning. Each day I'm learning. System operations. So they got a lot of other stuff on here, but like get into system operation. How to charge it? Different material. Look, CO2 vapor, industrial instrument or Coleman grade 4, break, vacuum, and pressurize to 150 psi of vapor. This is important because if you don't, you're going to hit that triple point if you're trying to charge with liquid, and you need to break it with vapor. Would I go up to 150? I don't know. Like they say that they want their system up to 50. You need to be above that triple point. So if it's 100 psi or 125 or 150 or 10 bar or 9 bar, as long as you're above, well above that triple point where you're not going to cause potential dry ice, then you're okay. You're going to be able to charge in there. But once again, follow the instructions of the manufacturers. Depending on the technicians or the contractor that I talk to, they all usually do 100 to 125. Charging hoses, cylinders, liquid cylinders with dip tube. So step by step, they're talking about it through this manual, which I really like. They talk about how to charge the oil, the reservoir. I'm going to go down a little further. Man, 43 minutes gone by. I'd like to talk. Once again, if anybody has any questions, please shoot them in the chat. As you get through, it talks about the controls. And so this is one of the big things that I've been learning a lot more about is understanding the controls. A lot of people, and it doesn't matter what industry in controls can be scary. Something new, something that we don't spend a lot of time on. The technicians that spend the time learning outside of work controls, those guys are growing and those girls are growing way faster because there's so many manufacturers with controls. You got Emerson, Microthermal, Corel, Danfoss, Nova, RDM. There's a list of them. There's lists and lists of them. And they all have their little uniquenesses. But at the end of the day, they're all doing the same thing. Turning compressors on, turning fans on, opening solenoids, regulating valves. What you need to understand is understand the fundamentals of what that control is doing, why it's doing what it's doing, and then get into how it's doing it. Because you'll see every controller is doing the same thing. Turning systems on, turning them off, adjusting stuff here and there, monitoring temperature. This is important to do this, to take the time to do that and understand how to do it. The big one's VFDs. Like when I was working at Copeland, I used to talk a lot about putting VFDs on the compressors. And there's so many technicians that I talk to, and even not even technician, refrigeration, people in refrigeration would be like, they didn't even know, end users didn't know they could put a drive on the compressors that are already out there. And once again, it's scary, it's different, but all it is just regulating the capacity, the mass flow of that compressor. And there's limitations. You got to go find those limitations out to get a better understanding. Different compressors are going to have different limitations. You just need to understand that and put those specific parameters in there. All you need to do is read those guides, understand them. Yes, are they thick? Sometimes they're 100 pages. But if you want to be different than the next person, that's what you're going to do. You're going to spend the time to do that stuff. And there's so many, well, even me, and I won't lie, I was caught up when I first started out where taking training programs, I thought it was, company owed me. If I wasn't I wasn't being paid for a training program, that I shouldn't be going. That is such a bad mindset. I was totally wrong with that. The people who told me that, it wasn't right. You need to go and do training on your own. It's so important. It's so important to do this extra training because that's going to make you better at what you do in your career, especially in CO2. There's so many different things that you're going to learn about in this. I think I've seen something up here. Look, hot gas dump valve, liquid injection valve. Understand what they do, why they even have them. They have them even on refrigeration systems now. Like you'll see in low temp applications, you got demand cooling, you got liquid injection. That's to keep that down, the temperature down, for an example. When we get down in the maintenance and troubleshooting section of this manual, it dives in on how to do a proper pump down. And this is one of the big things that I've talked to a lot of people that they're a bit worried about. Like Trevor, I worked in lots of HFC systems. I know how to pump that down. I don't know how to do a CO2 system. Well, it explains right here in the manual. Is there a few other things you should be watching them for? I read through this a couple times. Yes, I think there's a few other things that could be added to this manual. But once again, you want to follow the guidelines. You want to understand. You want to ask someone who has done it from your company or from that manufacturer who's coming out to teach you, if they are, or call them up and ask them that question. I know for sure if you called up Kysor Warren and asked them to get the question on how to properly pump down, someone will give you the answer. Maybe that first person won't. Maybe they won't be helpful at all. This happens at some manufacturers. Maybe they will. But there's someone inside this organization that wants to help you. I know this because I've worked with the manufacturer before. There might be some people that don't really want to help. It's a Friday and they want to get you off the phone. But there are people who want to help you. They want you to succeed because that means you're going to come back. You're going to talk good about that manufacturer. They really helped you in a tough time and they got you up and running. So this is a good example of how to go through it. Restarting a system after pump down. There is steps to do it, step by step. Like there's 15 steps in here in this manual. I'm not going to go through all of them because there's a few other things I want to go through. Pumping down a system, starting a self pump down. And this is the difference. This is why I like the auxiliary unit. Because if you're running that auxiliary unit, you don't have to really stress about specific step-by-steps. You still want to do the step-by-steps. But if you had an auxiliary unit and you had to shut down, a lot of systems that I've seen that I've been at, there's emergency shutdown procedures, and it'll turn on that auxiliary unit. And there's a process built into the controller, seen it in the microthermal, and it's step-by-step. You have to go into emergency shutdown and it's set up. It starts to shut down the rack and then turn on the auxiliary unit. But this takes a lot of pressure and stress off that, once again, that person working on the equipment. And when you dive down into it, they get right into the troubleshooting thing, step by step. Is there more to it? Yes. Like I went through this manual a couple of times. But there's a lot to it. Understanding the manual is important. When we get into this, the Advancer CO2. So this is the Hill Phoenix one. Advancer Europe has a different one, and I highly recommend going to get that one as well. What you have to do is go to the Advancer website and get onto their client portal, and they'll hook you up with the specific manuals, the PIDs for their systems. So much great information coming from Advancer. This is the Hill Phoenix one, Advancer. So step by step, once again, you want to go through it. This one here is 66 pages. You could think, this is a lot. Oh man, I can't read through 66 pages. It's so much. But if you take your time and go through it slowly, start today, by Christmas time, you could have it read and have multiple manuals taken out, multiple good points of information. Okay? Because the more you read it, the more each time you're going to learn something new. And take good notes. That's why I say take good notes of each section. The big one here is down to A3. Like you can go through this, it's going to be similar, but down to the appendix. This is where the pre-startup guide is, the startup guide, and the startup guide. Super important. But as we go through, as you can see, Hill Phoenix is the same thing. They have lots of pictures inside, a little bit more writing, as you can see, compared to the Kysor Warren one. But that's okay because there's lots of information. But if you get down, here's the installation and startup guide. So it talks about the different field piping, the pressures, the type of copper. This is something that's pretty important. If you're in Canada, it's going to be different than certain parts of the US, definitely different in Europe because there's new copper out there. As you can see here, it'll talk about different types of copper. And you can have either I think it's XHP 120. That's the Mueller stuff. You can also have you're going to see here of a K65, which is another one. This is copper iron alloy. And so what you really need to understand is where you can and cannot use that. Because I'm still looking up some of the answers here because I've seen racks installed here in Canada that have on the rack itself, because it was manufactured in UL rating by the manufacturer, that have this high pressure copper on it. But after the rack, you have to pipe from stainless steel all the way up to the gas cooler. So this is what I'm starting to learn. Like fittings may not be approved. The piping may be approved and not approved. So I'm starting to even learn this. So I don't even have all the answers for that. But I've been talking to different technicians out there and different companies, that say that field piping has to be stainless steel here in Canada in certain areas. So this is something that you need to check to follow the guidelines and understand what you can and cannot do depending on your local jurisdiction. It's so important. And as you can see, XHP up to 2-in-1 is rated up to, it says 130 bar. Okay, so you just want to make sure that you have the right one. It's recognized, third party recognized by UL, recognition for continuous high pressure operation up to 130 bar. That is UL, but doesn't mean that specific local jurisdiction is more stringent or more strict. So you want to look that stuff up, and I'm still looking up that stuff. And then here it talks about the K65 high pressure copper. So these little tips and things that you really want to know and need to know, I think is pretty important. When you take the time to find out exactly the reason why things are done, because you're going to see in some areas it's done differently, and that's just the way it is. It's kind of like high ambient solutions. I talked about it with Andre Patino, I think in episode 4 or 5. I can't remember what episode, but we talked about the high ambient strategy, the warm ambient strategy. Different places is going to have different types of equipment, different types of options to make sure that it works and get better efficiency, better coefficients of performance. And that's important too. Understanding how to bring the most value to your customer or your company. Because if you're working out there and you're seeing it and you understand this stuff, you can bring this stuff up with the project manager, the sales manager, even your boss. Yes, maybe they're not making the decision. Maybe it's coming from the end user, but it's something that they can bring up to the customer. That's bringing value to them. And the more value you bring to your company, the more they're going to look at you. There's more opportunity for you. You have to be bringing more value to them than you're getting from your company. 100%. When you're bringing more value, there's going to be more growth for you. That's just the way it is. You got to continue to bring value all the time, and you can do it. But by doing research, learning more about CO2, bringing this stuff into I was working with one contractor and talking about different solutions that I've learned about over the years, and they're like, oh man, we didn't even know. That's such a great idea. I'm going to bring it up with my customer. And they've been doing this, installing CO2 systems for years and years. They got dozens of them under their belt. And so this is just why the conversation is so important. Being curious, bringing this stuff up. And then as you could go down through here, same thing, not as many pictures. It's a bigger manual. It's a bit more in depth on their system, as you can see. But when we get down to the dependence, there's the troubleshooting section on the Hill Phoenix Advancer one. And once again, you can just search this on your phone on Google and find this stuff. Like I said, there's some manufacturers that it's difficult to find their stuff. So you call them, you email them, you send them, because there's a few that I'm already emailing now. I'm like, where's your manual? And honestly, some of them say, Trevor, we're just figuring out how to get a manual out there because we don't have a full manual that's released yet. That's what some of the manufacturers are doing, and they're not small manufacturers. So you got to work with them to find this stuff out. Yeah, you get it in the pre-startup, and I really recommend reading this stuff multiple times, going through it step by step, understanding. Once again, pressure testing. Nitrogen with nitrogen or whatever you need. Triple evacuation again. This is another one I want to pull up. Once again, there's lots of people that say you don't need to do triple evacuation. If the manufacturers are saying it's important to do, you should do it. Does it take more time? Does it cost more money? Yes. I know I talked to some contractor and they say they use thousands and thousands and thousands of pounds of nitrogen to pressure test their system to make sure there's no leaks. So when you're quoting a job as well, you need to put that stuff in there. Something that I never even thought about, but you need to quote the amount of nitrogen or whatever you're using to pressure test your components. And then the other one was the Hussman manual, another good manual. I use a lot of these in my trainings. These are suggested readings in my trainings, but so important to go through this. Getting heat reclaim, heat rejection, throttling valve, oil management system, step by step learning this stuff. Is it hard? Yes. This one has 42 pages. So we just talked about 130 some pages of different manuals, which is very important to take your time to do this stuff. And I know for sure those of you who start to do this, start to take more courses, starting to learn either internally, externally, you're going to start to see a difference in the knowledge that you have and the way you have conversations about CO2 with other people that know about CO2. And really what I love about the people in the CO2 industry, they want to help. Like I have so many people that are in Europe that are sending me information, trying to help grow my knowledge in CO2, and especially here in the US and North America as well, trying to help me grow. I had a conversation with one manufacturer last Monday for almost an hour, just helping me understand oil management, helping me understand heat recovery, heat reclaim, and the different options of it, and the way different manufacturers do it, and why they do it that way. Not saying the other ways are wrong, but they do it this way for these different reasons. And I really appreciate everyone sharing that knowledge with me, because this is why I do this, is try to share the knowledge with other people out there so that you can continue to grow. So you got to invest in yourself. You got to make the time to learn about CO2. It's already here. So especially if you're in supermarket refrigeration, but the amount of condensing units that I see manufacturers working on right now, the manuals that I've found from different manufacturers have CO2 condensing units. So many of them, almost, I don't know, maybe all of them have them. Maybe all of them. I don't know, but a lot of them do. All the major players in the supermarket industry have a CO2 condensing unit, either in R&D or in development and release. So we're going to see more and more and more CO2 from heat pumps to chillers. I'm super excited. I'm still going to do my best to share as much knowledge with all of you as possible. I want to thank you for taking the time to hang out with me today, to learn a little bit about CO2, how I find information on CO2 from the different manual manufacturers. I want to thank Kysor Warren, Hill Phoenix, Hussman for putting that information out there so I can learn to share with all of you. And I really appreciate if you can take the time to share this with somebody. Share one thing you learned today with somebody else. That means a lot to me. You don't have to share it. If you want to share it on social media, even better. But if you just share this knowledge with someone you work with, talk about either the manuals or the pressures or about CO2 or the critical point or the triple point, whatever it is, share that knowledge with somebody else. That's what's so important. And that would mean a lot to me if you can share that knowledge to help someone else out, because they're going to start seeing this stuff. And I don't want technicians to have to go through what I went through, stressing out on calls, stressing out on service calls until I spent so many years on breaking stuff and making mistakes and messing up to figure out, okay, I've done this before, don't do that again. We really need to help grow that, because there's so much information out there. It's hard to learn it all. So how do we guide more people to the right information, to learn things a bit quicker, and to really get to the next level? Oh, awesome. Someone says they're pulling the manuals now. So that is awesome, because this is important to research that and send those manuals. If you own a business, send it to all your technicians. If you're a technician or a refrigeration professional, send it to all your friends. And they'll be like, what's this? I don't read manuals, delete. Fine. But maybe one of those people will read it. And that person, you tell them to share it with 10 or 15 other people. And it could be whatever manufacturer you want. It could be a Danfoss, a Copeland, an Emerson, a Bitzer, whatever the manual is in CO2. Send it to someone and ask them, can you tell me what you learned from that? This is how we're all going to grow together. And those that invest the time, put the work in, are going to be the top people out there in our industry. I want to thank you all for taking the time, following the Refrigeration Mentor podcast, and hanging out with me on CO2 Mondays. I got a lineup up until the New Year's of some amazing guests. I'm super excited about this. Can't wait to see you at the next CO2 Monday. Have a great day, everyone.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.